We are given that the length of the base of the box is three times the width of the base. So considering x centimeter as the width of the box, the length of the box will be 3x. And let's say the height of the box be h centimeter. So let's find an expression for the height of the box in terms of x. And we're also told that the volume of the box is 40 meter cube. So first we write the expression for volume. Volume equals length times width times height of the box. We now write the expression for length. Length is 3x times width is x, and then multiplied by h, that is the height of the box. And this is given as 40 meter cube, so I put 40 for volume. Using this equation, we can determine the expression for h. So therefore, h equals 40 divided by, this is 3x times x is 3x squared. So this is the expression for the height of the box. We are also given the cost information for each of the sides. That is, we have four sides for the box. It is given as 1 pound per meter square. And for the top and bottom sides, it is given as 3 pounds per meter square. And in this situation, we have to determine the dimensions of the box, which minimizes the cost. That is, the cost of the material required to construct the box. So we now write an expression for the cost function in terms of x, and use calculus to determine the value of x such that it minimizes the cost. So since we are given the cost information for the sides and the top and bottom sides separately, we will write down the cost function separately. So first let's calculate for the front and the back sides. So this is front side and this is back side. So to determine the cost, we have to find the area of the front as well as the back side. Just observe that the front and back side are symmetrical. That is, we can just calculate the area of the front side multiply by 2, which gives the sum of the areas of the front and back side, and multiply that quantity by $1 or 1 pound, which will give the cost. So let's write down for front and back. Let's say this is cost is C1. So this equals area of the front and the back sides times the cost of the sides. So first let's calculate the area. Uh, Here we see that for the front side, this length is 3x, and we have a height over here. So height is h. We can replace the value of h as 40 by 3x squared. So therefore, we can write down C1. This equals area equals, we can multiply this quantity by 2 because both the front and back sides are symmetrical. So we calculate for one of the area. So 2 times of 3x times of height. Height is 40 by 3x squared. And this multiplied by the cost of the sides. Cost of the sides is 1 pound. So you simply multiply by 1. So let's simplify this expression. So this gives C1 equals, we cancel this 3's, and we also cancel the power of one of the x. So we get in the numerator we have 2 times of 40 is 80, and in the denominator we have only x. So this is the expression for cost function of the front and back. Now let's write down the cost function for the right as well as the left. So this is right side, and this is left side. We can see that these two are symmetrical. That means we can calculate for area of only the right side and use it to calculate the area of the left side also. So we have a length as x and height is again x. So let me do it for the left or right. Let's say this cost is C2, and this equals, once again we multiply by 2. And if you observe from the diagram, we have the length of the box of the right side is x, and the height, we have a height. So it is x times h. So we multiply x times h, we know that it is 40 over 3x squared. So this is the area times the cost of the sides. This is sides is once again left or the right side. So we place this cost of the sides as 1 pound. So we multiply by 1. Now let's simplify this. So this gives C2 equals, we can do the cancellation of x with x squared. 2 times 40 is 80. So we will get 80 by 3x. This is the expression for the cost C2. Now let's write down for the top and bottom. Notice that for top and bottom, it is the cost is 3 pounds per meter square. Now let's write down the expression for the top and bottom. So we can see this. This is top, has a length of x and length of 3x and width of x. So it is, let's say for top and bottom, this is equals C2. And once again, this is twice of the length of the top or the bottom is 3x and the width is x. So multiply by 3x times of x and multiply by the cost, which is 3 pounds per meter square. So we will get this expression. So this is equal to 2 times 3 is 6, 6 times 3 is 18. So we get 18x squared C2. Sorry, this is the expression C3. Now we have to add all the cost expressions, so we get the total cost expression. So therefore, let's say the total cost expression is TC. This equals C1 plus C2 plus C3. So let's replace each of the cost expression. C1 is 80 over X. C2 is 80 over 3X. And C3 is 18X squared. And this expression can be further simplified. Notice that these two are almost like terms. We just have to multiply and divide this quantity by 3 as plus divide by 3 so that we get least common denominator of 3x and we can add them together. So this becomes 80 times 3 is 240 and x times 3 is 3x plus we already have this 80 over 3x plus 18x squared. So this gives 240 plus 80 is 320 over 3x plus 18x squared. So this is the expression for the total cost of the material that is required to construct the box. We will now use the first and second derivative test to determine the dimensions of the box such that the cost is minimized. So here we have the cost function. So first we have to find the critical numbers of this cost function. So we can find it by finding the derivative of this cost function and setting up equal to 0. That is, the critical numbers are obtained when this function, let's say this is Tc of x, or we can simply say this as C of x. And so this, that is the derivative equals 0, we get the critical numbers. So let's find the, maybe I can just mark this as C of x, this also this cost function C of x. So let's find the derivative of this cost function. So this is equal to C prime of x. This equals, we have a 320 over 3. So I write down that as it is and then multiplied by 1 by x. So we have to find the derivative of 1 over x. Can do this using the power rule. So this is considered as x raised to the power of minus 1. And we apply the power rule, that is negative 1 times of negative 1 is negative 2. So therefore this becomes negative 1 over x squared. So the derivative of 1 over x is negative 1 over x squared plus the derivative of 18x squared, which is 18 times of 2x, which is 36x. So this is the expression for the first derivative of the cost function. We have to set this equal to 0 so that we can determine the critical numbers. So we replace C prime of x equal to 0. Therefore, this becomes 0 equals, this is negative 320 over 3x squared plus 36x. We solve for x from this equation. So I add this quantity to both sides. When I do that, I get 320 over 3x squared. This equals 36x. We solve for x. So I multiply by 3x squared first and then divide by 3 times of 36. So we will get x cube. This equals 320 divided by 3 times of 36. So this equals 320 divided by 108. So we have the equation x cube equals 320 divided by 108. We then take the cube root on both sides, so we get the value of x. So therefore x, we plug this into the calculator, and when we do that, we get the value of x as approximately 1.44. So this is in meters. So this is one of the critical numbers. We can determine if this critical number gives the minimum cost. So for that, we have to use the second derivative. That is, we find the second derivative of the cost function, and we have to check if the second derivative at the critical number is greater than 0. Only if it is greater than 0, we say that the cost is minimized. So let's do that. Let me take the first derivative, so which is, let me copy it here. That is c prime of x. We have negative 320 over 3x squared plus 36x. So let's find the derivative of this c prime of x. This becomes c double prime of x, which is the second derivative of the cost function. So this becomes negative 320 by 3, and we find the derivative of 1 by x squared. And this equals x raised to the power of minus 2. We find the derivative. So we apply the power rule. Therefore, this becomes negative 2 times of x raised to the power of negative 2, negative 1, which is negative 3. Or else this is equivalent to minus 2 by x cube. So the derivative of 1 over x squared is negative 2 over x cube. We then have this 36x. Now this is equal to negative times negative is positive. So 320 times 2 is 640 by 3x cube plus 36x. This is the expression for the second derivative. We now take this critical number and plug it into the second derivative. And when we do that, we should see that if it is coming up as greater than 0. And if it is greater than 0, then we say that the cost is minimized. So clearly we can, even before plugging in, we can say that whatever the value, uh, uh, in case if x is negative, then it might be negative. However, since x is positive, this quantity will also be positive, this quantity will also be positive. So sum of two positive numbers will be positive. So we don't need to find the exact value, we just need to understand the sign of this second derivative. Clearly this is coming up at greater than 0 at the value of x equals 1.44, and this confirms that according to the second derivative test, the cost is minimized. So we can say that cost is minimized at x equals 1.44 meter. We now find the corresponding dimensions. So x basically represents the width of the box. That means the length of the box is 3x. So let's write down the length, width, and height of the box. So therefore the length equals 3 times of x, and this gives 3 times of 1.44 meters, and this is equivalent to 4.32 meter. The width of the box is itself x, so the width equals x and this equals 1.44 meter. And the height of the box, we have the expression for the height of the box, which is 40 over 3x squared. So we can replace that. So I'm going to replace height by 40 by 3x squared. So when we plug in x equal to 1.44, we get 3 times of 1.44 quantity squared. And this, when we plug into the calculator, we get the height of the box is 6.43 meter. So we have determined the dimensions of the box, which minimizes the cost. This is the length, this is the width, and this is the height. Now let's find the corresponding cost. So for that, we will utilize the cost function. So we have this cost function. Let me copy the cost function. This is 320 over 3x plus 18x squared. So I write down 320 over 3x plus 18x squared. So basically we have to plug in x equal to 1.44 into this expression. So therefore this becomes C of 1.44, and this equals 320 divided by 3 times of 1.44 plus 18 times of 1.44 quantity square. So therefore we simplify or we plug this into the calculator, and when we do that we get the cost as in terms of pounds it is 111.4 pounds. So therefore we see that the total cost of the material is 111.14 pounds.